Have you ever stopped and wondered why the internet sometimes feels like two completely different things? On one hand, it's this super reliable place where information is just perfect. But on the other hand, it's a world of glitches, frozen screens, and weird digital stutters. Well, believe it or not, that's not an accident. It's actually a deliberate choice baked right into the heart of how the internet works. It's a tale of two philosophies, and it shapes everything we do online. Let's dig in.
I mean, think about it for a second. You're on a really important video call, and boom, the audio cuts out, or the video just freezes for a moment. It's super frustrating, right? But here's a question for you. Have you ever gotten like half an email or loaded a web page and found entire paragraphs just missing? Almost never happens. The whole message always gets there, perfectly intact. So what is going on here? Why does one experience feel like it's all about speed, even if it's a little messy, while the other is all about flawless, perfect delivery, no matter what?
Well, the answer to that little mystery is hidden deep inside the internet's architecture, in a part of the network called the transport layer. The best way to think about it is as the internet's invisible traffic director. Seriously, every single time you use an app, your web browser, your email, a game, the transport layer is humming along in the background, managing all the communication and making sure the data actually gets from some server out there all the way to your screen.
Okay, so to manage all this traffic, computers use something called a protocol. And really, a protocol is just a set of rules. The source material has a great analogy for this. Think about a teacher asking a class, any questions? You raising your hand, that's a specific message. The teacher then calling on you, that's a specific response. It's a protocol for having a conversation. Well, network protocols are pretty much the exact same idea, just for computers. They spell out exactly how to start a conversation, how to send the data, and how to end it.
And this right here is the key to everything. The transport layer doesn't just have one way of doing things. It gives our applications a fundamental choice between two very different services, two main protocols. And the choice that an applications developer makes is what determines whether your experience is going to be fast or flawless. So this brings us right to the heart of our story, the showdown between guaranteed delivery versus best effort delivery. You can think of it just like picking a delivery service in the real world. If you need to send a super important legal document, you're going to use certified mail, right? With tracking, delivery confirmation, the whole shebang. But if you're just sending a quick postcard to a friend, regular mail's totally fine. It's fast, it's cheap, and hey, it'll probably get there. The internet is constantly making that exact same kind of trade-off. And this slide really lays out those two philosophies in action. Over on the left, we've got TCP. That's our certified mail. Before it sends a single thing, it does a formal handshake to set up a reliable connection. Then it numbers every single piece of data, tracks it, and makes sure it all arrives in the right order. That's why your emails and web pages are always perfect. But then on the right, you have UDP. That's our postcard. It's connectionless, no handshake, no setup. It just starts firing off data as fast as it possibly can, with almost no overhead, basically just hoping for the best. So this brings up a pretty obvious question, right? If UDP is literally called unreliable and offers no guarantees, why on earth would any developer ever choose to build their application with it? It kind of sounds like a recipe for disaster, doesn't it? Well, as it turns out, there's a really, really good reason. And that reason, in one word, is speed. For some things, getting the data there fast is way more important than getting it there perfectly. In the world of real-time communication, good enough that arrives right now is infinitely better than perfect that arrives too late. Let's circle back to that video call example. So let's say a tiny little packet of data, just a fraction of a second of audio, gets lost on its way to you. What would you rather have happen? Do you want the whole call to just pause and wait while the system works to resend that little lost packet from a few seconds ago? Of course not. That would be awful. By the time it finally arrived, the conversation would have moved on. That old data is completely useless. For these real-time apps, it's so much better to just skip over that tiny little glitch and get the next piece of data as fast as possible. So who's in this speed first club? Well, it's all the applications where being in real time is what matters most. Internet phone calls, live video conferences, streaming a live sports game, and online gaming, they all depend on UDP's speed. Even the domain name system, that's DNS, the thing that turns website names into IP addresses, uses UDP. Why? Because getting a fast answer is more important than a guaranteed one. If the request fails, your computer just asks again. The tiny potential delay is totally worth the incredible speed you get 99% of the time. So, you see, it's never really about one protocol being better than the other. It's all about developers making a smart choice and picking the right tool for the job. It's about matching the transport protocol to what the application actually needs to do. And this table just lays it all out perfectly. Web browsing, sending an email, transferring a file, all of those things absolutely need every single bit of data to arrive correctly. So they use the reliable TCP. But what about live video streaming, which often uses another protocol called RTP that's built right on top of UDP, or your video conference calls? They absolutely need speed and low delay above all else. So they embrace UDP and accept that an occasional tiny glitch is a trade-off that's well worth making.
So the big takeaway here is this. That split personality of the internet we talked about at the beginning, it's not a flaw, it's a feature. The fact that we have these two options, one for total reliability and one for pure speed, is what allows the internet to be so incredibly versatile. It lets it be a perfect library of information and a real-time global conversation platform, all at the very same time. It's really a masterful piece of engineering that quietly shapes everything we do online. And that leaves us with a pretty fascinating question to think about. As our world demands more and more instant, real-time content, from live streaming to the metaverse and virtual reality, which of these two philosophies is going to win out? Are we building a future internet that prioritizes speed over everything else? Or will we figure out new ways to get both speed and perfection? Is the future of our digital lives going to be fast, or is it going to be flawless?